Oh. Okay. So there are some concluding remarks. If you remember, I'm not sure if even if you remember, I distributed some pieces of paper. There were a couple of problems. Those are the last two problems of polar coordinate system actually. If you want, right at the end of this class, I can post them again probably. So I'm not going to do it. We will start a new topic. Rigid body kinematics is done. Polar coordinate system is done. We are starting a new topic. Do you have any concerns or should I start? Okay, I'm definitely starting a new topic. Our new topic is unconstrained motion. I hope you had a good exam. Just a quick remark. Your midterm exam 1 graded will be returned to you after Eid, because I will be grading the exams during the holidays, if that's fine. Constrained motion. So yes.
Of course, we are not going to calculate any equations of motion. So
Sorry?
we are not in this course. We are not going to
For sure we will. 100%.
For example, does the same go for the actual 6-meter long distance in holidays? We usually grade next to 6-meter long distance to
Yes, 100%. The answer to your question is yes. So what we will do is I will go over the Newton's law, but if time allows me, we will go over one more technique to find the equations of motion. I will try my best. But if I don't cover the finding the equations of motion, then the whole discussion of dynamics is pretty much useless actually, because at the end of the day, this is why you are going through dynamics. So good remark. Then I have point B here. I'm sorry. There is a person sitting in this car. Then this gentleman, or whoever is this person, then there is a circular path. Please bear with me. Usually before the class, I make these drawings, but you all know that we have a 206 and I don't have time. So we have to go through the drawings. Then I have a straight path here. Then I have a straight path here. Just bear with me. Now there is another person very casually driving the car. So one thing very funny that you will find is that you already have covered the complicated part of dynamics. The rigid body kinematics is not easy, by the way. I'm not sure how many found it easy. This is easy, by the way, what we are doing right now. Now, this gentleman is A. This person is B. And the question says that this is unconstrained motion. What does that mean? Oh, what happened?
there is no friction.
Unconstrained motion means that they are not connected with a rope. They are unconstrained, right?
But are the two different bodies or one?
Yes, that's what I'm saying. Different cars. It's not like one person arrives there. No, these are different persons. Different. Good question. Different objects, actually. Two cars. The question says that find velocity of A. By the way, this is not rigid body kinematics, right? Find the velocity of A with respect to B. This is,
It's relative.
huh?
It's like relative.
हाँ.
Relative speed of the.
I will, good. I will say. So I am the one who is driving, who is sitting in the car B, and I take my head outside the window of my car B, and I'm looking at the person who is driving the car A. That's the problem. Okay. Find the velocity of A with respect to B. I'm sitting in car B. I took my head outside the window.
So we will solve river problems to the box.
We don't solve.
We will solve river problems to the box, and you know the speed of the turbulence.
It's the same subject. You see it in high school, you see as a how the B driver sees A driver.
Oh, okay, yes, probably. Yes. I actually did not, I did not know this. Okay, so we have, why don't you do this problem for me? Now, I will say that, I'm not sure this is the right time, but I will make a comment here. We are going a little out of the way, but I think this is the right time for me to tell you something. VB equal to, I think I need to restart my laptop today. VB equal to VA plus omega AB was the formula for rigid body kinematics. So there is a reason I'm using them. I will use, let's say, E and F. If our online student can tell me if he can hear me, if he or she can hear me, position of E with respect to F plus, this was in rigid body kinematics, slash F small xyz. Now, I will explain something which I haven't probably before. This portion, this chunk is what is known as, this chunk is VF, this chunk is VE. Okay, what on earth do I even mean by this? I will tell you. What happens is that, if you just imagine, there was this collar, right, sliding on that rod, and the rod was also moving like this. So if you think about it, when I was talking about the velocity of that collar, at the end of the day, the velocity of that collar constituted different components. Number one was if the base was itself moving or not, that's the VF. And 90% of the times VF was zero, right? That point was zero. Boom, gone. Then the rest of that chunk was how that collar is moving with respect to that stationary point F, right? Whether it's going like this or it's going back and forth. So this chunk was nothing more than E with respect to F. So you put me on that collar, then it's my velocity at the end of the day with respect to that stationary point. I never mentioned this, but I think it's high time that I tell you. In fact, so please, this is rigid body kinematics formula, and I will remove it very soon. Then I will also take the liberty right now to explain, which I have this bad feeling that I need to restart the laptop. Mehmet, can you hear us? If he can actually double check if he can hear me properly. Okay, anyways. So the other one is AE equal to AF, and AE equal to AF plus omega EF. That big formula, I'm not even sure whether you remember this. Position of E with respect to F. Yes. Very good. Plus alpha EF cross position of E with respect to F plus that giant term. No, this is where the mistake can happen. Omega cross V. E F cross
No, V, E, F.
E with respect to F. Okay, let me use a PDF. V E with respect to F, small xyz, plus A E with respect to F, xy. So I will take the liberty to tell you today that this chunk, nice and beautiful, is our AF. But this big chunk is, look at this whole thing is AE with respect to F, and this big chunk is, oh sorry, not even big, AE. Boom. So from here onwards, if someone says, what is the meaning of this slash? It's very easy, huh? It's AE minus AF. What is the meaning of VE slash F? It's VE minus VF. And I will take the discussion back to where we started. What on earth does this mean? They mean velocity of A with respect to me, who is looking from the window, which is equal to
VA minus VB.
VA minus VB. VA minus VB. Okay, so I think we are all on the same page today. So let's get back to the discussion. Okay, now the first thing is you have to come up with a coordinate system. Then you can start the problem. So this is my Y. This is my X. Boom. And you can also write and acceleration of A with respect to P. Okay. So in order to do this problem, you have to have a clear idea that actually the object B where I am sitting is on a straight path, whereas this fellow is on a curvilinear path. So I will say that velocity of solution I have started, by the way, from here, VA with respect to B equal to VA minus VB, done, which is equal to, now the VA is on a circular path, so I will write VA E R E. No, I think normal tangential is easy for me, although you are right actually. You said E? No. Theta. Theta, not R. It's normal, so the person will not turn and go to the grassy place. He or she has to stick to the road.
Yes.
So E theta was correct, by the way. Good answer. ET, but I'm using normal and tangential. And minus V, B is VB. So I will say VB iota. Sorry, not iota. I mean I, unit vector. Now for A, I will put yellow marker. And I will say this is my normal. Normal was towards the center of curvature, right? Right? This is what we agreed on, towards the center of curvature. And for ER, it was, I think, away from the center of curvature towards the increasing R. So this is by E caret N. And for tangential, we used to say in the increasing towards the motion or towards the velocity. So ET was like this. Not sure whether how many students agree, but I think this is good. Now, finish this problem. We need theta as well because I cannot talk about his motion or her motion. So I will say this is my theta. Probably I should have given you before. So I will say, according to the given problem, it will be VA. So if the velocity is in this direction,
So we minus theta.
okay, I will answer. I think you are right. This is VA. So it will be if this is theta,
With respect to x, it will be 90 minus.
theta 90 minus theta. I think he's right, by the way. This will be 90 minus theta. So it will be this VA cosine 90 minus theta. Okay. Cosine 90. What is cosine 90 minus theta? Cosine 90 minus theta is sine theta. Okay, you can. Okay, and then this is cosine component. For the sine component, I will do VA sine 90 minus theta. So it will be minus VA cosine theta, J component. I apologize for this, by the way. So this one we decided as I unit vector. Okay, left and right. I think we have arrived. No, minus VB. Okay, we are stopping here for 3 minutes. Is everyone with me? That's the important question today.
Yeah, that's really makes sense.
Right? What about sine 90? Sine 90 minus theta is cosine theta.
Sine 90?
Sine of 90 minus theta.
Yes, it's also.
It's also positive. So I think I put a negative because I had an idea. So that's why. Life is beautiful. So let's proceed. We have VA with respect to B equal to VA sine theta. I know that you will be like, why are we going through these expressions and why not numbers? Just to give you an idea. By the way. Done? VA sine theta I minus VA cos theta J minus VB I. So I took my head out of the window and this is what I perceived the car B, because the car B is going in a circular fashion. Okay, why don't you now help me with the acceleration then? Okay, I will start from here. With respect to B, that is me, it is equal to AA minus AB. Do it.
Does the B accelerating or decelerating? You don't know.
Yeah, okay, that's a good question, by the way. I did not decide, by the way. So you can consider AB in the positive I direction. So at the end of the day, we can give a positive number to B or negative. By the way, this is not easy, the task that I gave you. So I have to do in parallel. So we will have equal to, what is AA? Again, in a circular path, life is not good.
A times EN.
So probably do AA, E caret T.
And no.
There's a normal.
Yes, very good. Plus AA, E caret N minus AB iota, not iota, I unit vector. Sorry. Okay, and then last but not least, AAB equal to. Now, I will say AA. Did I make a mistake here? AAET, No. Did I or did I not? Hang on. I think I did. I apologize. There is a little mistake here. This will be AAT. This is a ginormous mistake. Did you observe the mistake I made?
Yes.
Because the tangential and normal components cannot be equal in general. So how can I use the same symbol? That was a big mistake. So you have to be super careful not to make these little mistakes in an exam. AAT. Now I can replace AAT with, I don't know, AA. So let me please think about it. So probably we need some diagram. This is not easy. So I have, let's say, this is a horizontal line. Then I have this blue color, nice and beautiful, as my E caret N, and this nice and beautiful as my E caret T, beautiful. Then this angle is my theta, and this angle is my, again, theta. And I think now I can decide how many agree with me. AA is accelerating, let's say, in this direction. So it will have a cosine. I apologize. 1 minute. So it will be AAT E caret T. So AAT for E caret T, I will say. Okay. Hang on with me. Please hang on with me.
Isn't it the same with the velocity one?
No. 1 minute. E caret. I will actually use this. E caret T is equal to E caret T is equal to it's the same thing, no? Yeah, of course. E caret T is equal to sine theta I minus cos theta J. Yeah, I think we already did it, so not sure why I'm not doing it again. Okay, thank you. And E caret N equal to, so now this is E caret T, E caret N is 90 degree to this one. So we can have
sinus theta J minus cosinus theta I.
Yeah, you said minus cos theta I. Okay, hang on. So this minus cos theta I. Okay, minus. Okay, yeah, good. Very nice answer. Minus cos theta I. And this is minus sin theta J, did you say? Yeah. Okay, I think all of you responded quickly. Very good. I appreciate it, everyone. Thank you. Then I will do number crunch, symbolic crunching. I will say it is A with respect to B equal to AAT. Thank you. AAT like this. Instead of E caret T, I will use what one of our students, couple of students indicated. Very good answers. Then I will put a plus sign. Then I will put AAN. Then I will put some brackets and I will substitute nice and beautiful minus cos theta I. Minus sin theta J. Please bear with me. I know it's lengthy. And then I will use some other color like a pink. Minus ABI. Oh, come on. Minus ABI. I need to have space. Minus ABI. So I will use a box like this. Oh, confusing, but finally. Now, to finish the question, I will use some space here and I will say that AAN. So I will actually take the liberty to write it here using this color. What is AAN?
Centrifugal acceleration.
So V square over V square, so it will be V A square over radius of curvature. Boom. That was one question, by the way. Take 5 minutes, absorb it. I just resolved the normal and tangential form. It's not even visible to you, but we are not going anywhere for 5 minutes. Just imagine. Tell me. It's confusing or
No, it's not something about I couldn't get the ET and EN modules.
So this is normal, that is tangential, right? So if my normal vector is like this, all I am doing is dividing my normal and tangential in the I and j unit vectors. So if my normal is like this, look, my minus cos theta I and minus sin theta j. That's how the two students responded quickly while I was just thinking. So they both said minus cos theta I and minus sin theta j. For the tangential, that arrow is like this, right? So positive cos theta I.
But it's not good.
Oh, no, sorry. I apologize. By theta, I mean 90 minus theta.
That will how does it become?
Yeah, this is 90 minus theta. Yeah, that's why. This is 90 minus theta. So it's positive cosine 90 minus theta I and negative sine 90 minus theta j. No? What about you?
I guess so.
You agreed?
Yeah.
Okay, gentlemen, ladies and gentlemen, let's proceed. So left and right, but we have got the answers. Oh, come on. So let me make a problem for you then. Oh, what on earth is this? So rigid body kinematics. Rigid body kinematics. This is not our discussion. I'm just writing it like this. Okay. So the problem is,
About previous slide, we say that velocity of E with respect to F is the whole chunk. Drop. So the velocity of E with respect to F, X, Y, Z, it's
No.
in smaller coordinate.
Okay, I will tell you. Velocity of E with respect to f, x, y, z is with respect to the rotating frame of reference. So there is this little x, y, z. You used a glue and you pasted it on that disk so that a small x, y, z is also rotating with the disk. And with respect to that, somebody started walking inward or outward. That's why we use the small x, y, z. And that's why I, in very easy words, kept on saying as the person is walking inward or outward. So why don't you please do this problem for me? You are giving me the values. VA is, VB is 18.5 meter per second. AAT is 5 meter per second square. Oh, hang on, 5 meter per second square. Okay, let me close these things. Okay. And then AB is 2 meter per second square. The radius of curvature is 100 meter. Theta is 45 degree. VA with respect to B, I took my head outside the window as the other car was taking a turn. Then I took my head outside the window as the other car was taking a turn. Give me this bracket. Give me this bracket. Give me this bracket. Give me this bracket. Boom. This is not rigid body kinematics. It's so easy, right? What you have already gone through was that was the tough part of the course, by the way.
First slide.
Huh? First slide. Like this one.
No, hocam, no. Previous one.
This one. Okay, so everyone can take a picture, by the way. One minute, like this. Probably I can remove this as well. 6, 5, 4, 3, 2, 1. 6, 5, 4, 3, 2, 1. 6, 5, 4, 3, 2, 1. And I'm stopping my video because I want to make this smooth. Stop video. Gone.
Can you go back to the previous slide? I have to ask.
Slide number 1.
This one. We replace acceleration of v in theta with v a square over r.
No. We replace the acceleration of A, normal direction, that fellow with half, not B. B is going in a straight path. B has nothing to
Yes,
do.
acceleration of a
A normal.
that's it towards the center.
A normal, not AAT, because AA also has two components. It has AAT. Look, AAT is still there as a symbol.
Yes.
But AAN, I used a green color VA square. Oh, sorry. Did I make it wrong? No, correct. Okay, everyone. I hope you can give me the numbers.
For the first one, I'm getting minus 11.4 I.
Okay,
0.7
11.4,
and minus 7.7.
7 point.
Zero, seven.
Well, I have one in my notes. Okay, from last year. Okay, what about this one? Think about it. Take your time. Okay, you are not responding, so I will just write it. What did you get here?
0.83.
Huh. Good.
4.3.
4.2 I have in my notes. Okay, done. Do we have anyone who has any questions? Okay, everyone. Life is beautiful, I guess. Should I proceed? Okay.
Which value can be used in this formula b square over radius?
Very important. Good. The very important critical question. Look, who is taking a circular path? A. Who has normal acceleration? A. Whose velocity I will plug in while talking about normal acceleration? V square over rho. A. V has nothing to do with the circular motion. B is just car going straight path. That fellow does not have a normal acceleration. Why would I even bother to think about his or her normal acceleration? A has the problem because he or she is going in a circular path. A has a normal acceleration. A has V square over rho. But AAT, I cannot play with it. Okay, everyone. Should I proceed? Everyone is with me? Positive? Okay, 6, 5, 4, 3, 2, 1. Okay. So I think all of you do understand this. So I will put it in a beautiful way in English. Relative motion, unconstrained. Students who said, what do you mean by unconstrained? Because both of the bodies do not
Different one.
are not, no, they are different, but they are not connected with a rope. They are unconstrained. I put the foot on the pedal or she removes the foot from the pedal. Both of us are not related to each other. Okay, so I think all of you understand. We have a car, then we have acceleration of this fellow. Then he or she has VA, nice and beautiful. Then this fellow is going very quickly. She has a velocity VB. She is deaccelerating, unfortunately. Whatever. The position vector. Okay, I know I'm going in the reverse order. Now you understand this. But anyways, this is position vector RA. Let's call it as XA. The position vector of this fellow, let's call this as, hang on for a second, RB. So this is my RB. This is my RA. RB. I'm calling RB as XP. It's okay. Life is beautiful. Then this is a vector. This is a vector. Now, I asked you what is position of B with respect to A. All of the students said B minus A. Then I said, what is the velocity of B with respect to A? Everyone said, take a time derivative. We have already done this, by the way, in the last slide. We are going reverse. Acceleration of B with respect to A. Everyone said, take another time derivative. Okay. But your textbook also uses this symbol. So I will say position of B with respect to A equal to B minus A, B relative to A. And your textbook actually writes XB equal to XA plus XB with respect to A. Now go to the rigid body kinematics, right? VB equal to VA plus, you get my point. Anyways, so I am more comfortable in writing it like this, VB minus VA. No need to write it again and again. AB with respect to A equal to AB minus AA. So you use the symbol X or R. I have no issues. Students who don't like the fact that I did not put arrow here, they can put arrow here if you want. It's fine. We have 7 minutes. Do you want to take a take-home problem? Okay, let's have a take-home problem for you. The problem is like this. We have a nice and beautiful train, actually, you know. Hang on with me, please. Hang on. The train is going like this. It has boxes like this. Okay, I'm not okay. This is not good. You know, once you start to make something like this on whiteboard. Okay, now there is a road that goes right through it. Okay, let me make a 45-degree angle. A beautiful car. I don't know. Is this a rigid body kinematics problem? No, no, it's not. The car has a velocity of 45 miles per hour. The angle is 45 degree. The train has a velocity of 60 miles per hour. These are constant velocities. Wow. Yes. The question says that you have to find the velocity of train relative to car. I think you understand that you have to take care of the direction, so I am removing the arrow, but it's fine. By the way, you can do it right now. So give me the answers in miles per hour, okay? No need to convert it into feet per second. Okay. I will also provide you with a coordinate system if we have a student who is getting confused. X. No, sorry, Y. And this is X.
Minus 28i
Already got it.
plus
Minus.
31j.
You flip it. Did I ask train relative to car? No?
Yeah.
So it is I minus J for me. 28.2 I minus 31.8 J. Okay, I will double check.
Oh, yeah.
Sure?
Yeah.
Okay, so he already did this, so I will do it for him. It is equal to, so I am sitting in the car, taking my head outside the window. Okay, by the way, it's not a good idea to take head outside the window. I'm just giving an example. No, these are recorded, by the way. It's not good. So we should never. Yeah, of course, this is recorded. So of the whole dynamics class, the only takeaway is that the instructor talks about taking the head outside the car. Let me use my charger. Okay, laptop is going to switch off, but anyways. So we have VT minus VC. What is VT? It is 60. I minus VC is 45 cos 45 I plus 45 sine 45 J, and very beautiful answer of VT with respect to C is equal to, as one of the students has already given us an answer, 28.2 I minus 31.8 J. Miles per hour, do not forget the units. Just because you have written an I and J does not mean that you can remove the units. And just to give you a perspective, we still have 3 minutes. Why on earth the answer is 28.2 I minus 31.8 J? Well, what happens is that as I am looking at the train not only appears to me going towards right, it also appears to be coming towards me, right? Because I am approaching the train is going like this. So I will have me sitting like this. And what happens is that I'm saying, you know what? The train is going like this. Okay, that is reasonable. But on top of that, there is a big Y component, negative 31.8, which is a little larger than this one. And the train appears to me like this. Wow. The train appears that it is coming towards me, which is pretty easy to imagine. So that is my V T with respect to C. That's my V. I forgot. What is this? V T X. This is V T Y. Boom.
No, VT.
Huh?
VT with respect to CX.
No. Oh, sorry. Yes. I think he's right. I think I was wrong. Thank you. I apologize. This is in the X and VT with respect to C. This is the Y. And I can, class is over, but I will just write one more diagram. There is another way of looking at it, that VC is like this. 45 degree. And the train is like this. Let me make the train. The velocity of train was higher, by the way. Right? So I try to, so this is V train. And the Vt with respect to C is, so there are students who are saying, how on earth can you draw this? Then my answer is that Vt with respect to C is equal to Vt minus Vc. And Vc plus this fellow gives me the pink line. So Vc plus this fellow gives me the pink line. Boom. Done? Any questions from me? Okay, thank you everyone. Have a good day. You can ask me a question. I will just pause the recording.
About torsion strength.
That's fine. That's fine. That's fine. So let me